Right, turn to 9.3 section, thanks to your booklets. We're going to now look at quadratics in a different form. This form is called the turning point form. So you see it's got there on the thing y equals a bracket x take b all squared plus c. That's called the turning point form. Can you write that at the top of your notes please there? This is the turning point form. Now in the turning point form there's three things we can change. We change what number goes out the front here, is changing an a value. That a is the same as our a in the quadratic formula. But this b and c here aren't the same as our b and c in the quadratic formula. So they're different, they're different b and c. So don't think these are the same b and c that we've been talking about previously. What we're going to do is investigate what happens when we change the values of a, b and c. We'll look at them independently first, so we only change one thing at a time, and then we'll have a look at whether we can change all of them together at the same time. Okay, I've got a little applet up here, program is called GeoGebra. You can download it for free off the net. And I've made up a whole lot of nice little applets, and if you want to get this and play around at home, it's good because you can actually change things. It's all that sort of, what happens if I do this sort of stuff, and try and see how it's changed. So this, currently we've got our basic parabola. Here's the rule here, y equals x squared. At the moment the a value is 1. The b value, there's nothing inside the square, so the b value is 0. And there's nothing added on the end, so the c value is set at 0. If you have a look up the top there, the top left-hand corner, I've got those a, b and c set at 1, 0 and 0. I can move those along those sliders and change the value of these. So the first thing we're going to do, if you look at the first investigation here, it says investigating A, we're going to draw these three graphs. So the first one, y equals x squared, that's that graph. So can you put that graph on there? I'll put the coordinates there for you so you can see what it is. So I'll give you a moment just to draw that one. Now you won't be able to plot the point 416 or negative 416 because your grid only goes up to 10, doesn't it? So plot what you can. This is the first parabola we plotted the other day, isn't it? Remember y equals x squared was the first example we did. So drill that in and label which graph it is. So on the graph you'll have something like this. And you write at the end of it y equals x squared. So you know which is which. Okay, so everyone got that one down? Right, so now the next one, Bailey, Mitchell, please. Next one we're going to do is look at the graph of y equals 2x squared. So I changed the a value from 1 to 2. Alright, the black graph is the graph of y equals 2x squared. The dotted red graph left behind is the starting graph, x squared. So just draw the black graph, please. First thing we'll notice here is we talked about x-intercepts and y-intercepts in our last lessons. The x-intercept and y-intercept for both these graphs is 0, 0. The turning point is also 0, 0. This is one of those cases where the x-intercept is only one x-intercept because it turns on the x-axis. So we'll still talk about those same four key features we talked about in our previous lesson, about the y-intercept, the x-intercept, the axis of symmetry, and also the turning point. So this is the graph of y equals 2x squared. Who'd like to tell me the difference between y equals x squared and y equals 2x squared? Similarities or differences?
It's just twice the amount.
Twice? What's twice the amount?
The y.
The y value's been multiplied by? 2. Okay. It's still got the same intercepts, still the same shape. How would you describe its shape compared to the original one? Nice and loud? Narrower. So that's the word we actually use in this case, it's narrower. When you get to year 11, year 12, we talk about transforming the graph. Okay, so dilations, or we talk about making A bigger makes the graph narrower. Okay, the next one we're going to draw is y equals a half x squared. So I'll change it on here. Have a look as I bring the value of A down. It goes to 1.5, back to 1, straight over the red dot. Now make it a half. How would you describe that compared to the original graph, which is the red dotted one?
Wider.
It's wider. Okay, so can you draw that graph in, please? All the y values now half of the original y values. The only comment I want you to write at this stage is this. This is your notes. Can you make sure you get it right, please? Okay, in the box below, underneath those three graphs, there's a box that says comment on the graph. The comment I want you to write is changing A will make the graph wider or narrower. Changing A will make the graph wider or narrower. I don't want you to draw these graphs. I'm just going to play around with A for a little bit here and just show you that. As I make A bigger than 1, you notice it gets narrower. The bigger the number of A, it gets narrower and narrower. As I bring the value of A back towards 1, the graph starts going wider, doesn't it? And if I go past 1 and go to a half, it makes that. If I make A 0, then it's not a quadratic anymore. The reason being is because it becomes 0x squared. There's no, to be a quadratic, it's got to have a number in front of x squared. That's back to the basic one. Alright, so A can change the graph, making it wider or narrower. Alright, let's go to part B. On the same set of axes, we need to draw these graphs. The first one says minus x squared. So I now change the... Yes, Dylan?
Are these going to be the hat shape one?
Yes. We talked about that the other day. Put a negative in front, makes it upside down. If I make it -1 for A, you'll get that graph. So can you draw that graph in, please, on that second set of axes in part B? What I'd like you to also do, can you put in the dotted red graph? That's the basic graph y equals x squared. That's the first one you drew on the other graph. Right, can you also draw y equals positive x squared, the dotted red graph up here, please? And label both of them. Discovered the other day when we were plotting graphs, if you put a negative in front of the x squared, it made the graph one of the hat-shaped ones, didn't it? And what we should note here, though, with these two graphs, is they're exactly the same shape, aren't they? Why is that? Who can tell me? Dylan?
Is the A is not the same, but just the opposite?
It's the same size, isn't it? They're both ones. One's -1, one's +1. But they've got the same size. In maths we say it's got the same magnitude. Okay. In fact, another way of looking at this, a lot of people will look at this and say, oh, it's a reflection of itself. Can you see that? That negative makes it reflect. When you do this sort of work in year 11, and year 12. So that's the first one, y equals -x squared. Make sure you've labelled it, please. So let's do a bit of prediction. The next one we're going to do is y equals -2x squared. How do you like to predict what it's going to look like? Hands up. Ricky?
Narrower.
Yeah, more information. Narrower and Brianna? Nice and loud. Hat shape and narrow. Let's see what happens. I'll change the value to -2. And yes, we can see it is narrower and it's also hat shaped. It's upside down. So I'll give you a minute or two to put that one in. If you need to hit what the numbers are, have a look at the one up above on your own graph from above. It's just like 2x squared, except it's upside down. Alright, everyone got -2x squared? The third graph I want you to draw in this section is the graph of -1/2x squared. Anyone like to predict what it's going to look like before we do it? Yeah, not narrower. It's going to be wider than the x squared graph. So let's change it to -1/2. And it is wider, but still upside down. Yes, both. After you've drawn the graph, while you're drawing the graph, I want you to think about what comment we'll put in the box.
I'm pretty sure.
Pretty sure. Alright, here's the last bit on this page. Pay attention. Here's the last bit on this page. What's the comment going? Who'd like to make a suggestion what we can write in this box? Ricky, nice and loud. Reflects the positive, yeah. No, I'm not happy with that for A. A does what if it's such and such? What are we investigating in this section? Brianna? If A is negative, it's a hat shape or upside down parabola. So write that in place. If